Hi, and welcome back to Holds Part 3B. Last time we examined the effect of crosswinds on the dimensions of a holding pattern. This time we are examining headwinds and tailwinds. For our first example, we are holding east of the VOR on the 09er 0 degree radial with the inbound track as shown here. Imagine there is an 18 knot wind from 270 degrees. For holds up to 14,000 feet, the inbound leg must be 1 minute. That creates a very convenient opportunity to use the same rule of thumb we used for crosswind adjustments in the last episode. In other words, 6 knots of headwind shortens the inbound leg exactly 0.1 nautical miles. So the 18 knot headwind in this case requires us to shorten the inbound leg exactly 0.3 nautical miles. I would like to emphasize that this rule is universal. Once you know the length of the inbound leg in zero wind for whatever airplane you are flying, shorten the leg by 0.1 miles for every 6 knots of headwind. By the way, to keep things simple, I am only explaining 1 minute holds. For high altitude 1.5 minute holds, the rule is 4 knots of headwind or tailwind changes the inbound leg 0.1 nautical miles. For the airplane we are using in this demonstration, the zero wind inbound leg is 2.2 nautical miles. So with the 18 knot headwind, it will be 1.9 nautical miles. Now that we know the inbound leg will be 1.9 nautical miles, try to visualize the rest of the hold. Most likely you visualize it something like this, but this won't work. Here's why. Up to now, every hold we have flown, the outbound leg ended abeam the start of the inbound leg. But with this wind, we are going to drift in the turn like this. Oops, we wound up right back at 2.2 nautical miles from the VOR. That's not where we want to be. In this turn, any airplane will drift back 0.1 miles for every 6 knots of headwind. So however much we adjust the inbound leg, we must always adjust the outbound leg exactly twice as much. In this example, the inbound leg is shortened 0.3 miles, so the outbound leg must be shortened 0.6 miles. Now it's too bad we don't have an instrument to directly measure when we are at this point, but we don't, so we must calculate the diagonal distance so that we can identify when to turn inbound. Pulling out a calculator to do the Pythagoras theorem in flight isn't going to cut it, so we need something simple. I hope you recall from last time that the diagonal should be adjusted by half as much as the cross-track was adjusted. But in this case, the rule I follow is to adjust the diagonal by twice as much as I adjust the inbound leg. We are shortening the inbound 0.3, so shorten the diagonal 0.6. 2.6 minus 0.6 gives us 2.0. If you care to use Pythagoras to calculate the correct amount, it's closer to 2.1. But this small error will result in less than a 5-second error and can be corrected second time around the hold by increasing the diagonal if necessary. Now let's give it a try. We are inbound to the Vancouver VOR on the 09er 0 degree radial. We are cleared to hold east on the 09 0 degree radial. The wind is exactly as we just briefed. So we are planning an inbound leg of 1.9 miles. I will start the stopwatch as we pass 1.9 miles so we can confirm that this gives us a 1 minute leg. Let's get a ground speed check to confirm. 131 minus 18 is 113. Yep, 113. So we do have an 18 knot headwind. When we get to the VOR, all we have to do is turn right to heading 090 and fly to a diagonal distance of 2.0. I'm waiting for the flag to flip. There it goes. Time. Turn. Right to 090. Track. The HSI and number 2 are already set to 270. Throttle. Fine-tune for 120 knots. And talk. Report entering the hold. As we roll out on the outbound leg, we start the stopwatch when the flag flips. We aren't going to use the time anyway, it's just for backup. Crosstrack is roughly 1.4, so that looks good. I simply wait for 2 nautical miles and then turn inbound again. There's 2 nautical miles and we roll into the turn. As we roll out of the turn, I start the stopwatch, and I note that the distance is just under 1.9 miles, so my time will be just a few seconds short. I now realize that I should increase the diagonal to 2.1 next time around the hold. If I do that, next time around the hold will be perfect. No need to demonstrate that, I think, so we will reset for another hold. This time we are cleared to hold on the 270 degree radial, and the wind is still 270 at 18 knots, so we have an 18 knot tailwind on the inbound leg. Just as with the headwind, the inbound leg must be adjusted 0.1 miles for each 6 knots of tailwind. So in this case we must increase the length of the inbound leg by 0.3. That will make it 2.5 nautical miles. Just as in the previous case, if you start your turn from the outbound leg abeam the start of the inbound leg, you will drift along a path like this and wind up back at the original 2.2 nautical miles. Therefore, we must extend the outbound leg exactly twice as much as the inbound leg. In this case, that means 0.6 miles. In order to locate this point, we must estimate the revised length of the diagonal distance. The rule I use is the same as with the headwind. I extend the diagonal twice as much as I extend the inbound leg. In this case, that means an extra 0.6 miles. So the revised diagonal distance will be 3.2 miles. Okay, now let's give it a try. We are inbound to the Vancouver VOR on the 270 degree radial, cleared to hold west on the 270 degree radial. We have an 18 knot tailwind. Since our true airspeed is 131 knots, the ground speed should be 149. Let's have a look. Yep, 149. We must extend the inbound leg 0.3 miles, so I will start my timer as we pass 2.5 nautical miles so we can check out the time for the inbound leg. There's no crosswind, so at the VOR I will turn right, heading 270, and fly until the diagonal distance is 3.2. Remember that I must extend the diagonal twice as much as I extend the inbound leg. Waiting for the flag to flip. There it goes. Time, turn, right heading 270. Track. The HSI and number 2 are already set to 090. Throttle, fine-tuned for 120 knots. And talk. We would report entering the hold. As I roll out on the outbound track, I expect a cross track of 1.4, 1.43, close enough for me. I just hold my heading until the diagonal distance is 3.2 nautical miles. force 3.2 when we roll into the turn. As we roll out, I start the timer, and the distance is 2.5 miles, so we already know we have a 1 minute inbound leg. That brings us to the end of the demonstration of headwind and tailwind. We have one more demonstration to do, combination wind. I will reset now for the final demonstration. Okay, it's time to deal with a combination crosswind and tailwind. The good news is that everything we have learned is fully applicable. To deal with combination winds, just apply the rules you have learned for crosswinds and tailwinds, adding the effects. For our example, let's say we have a 12-knot crosswind from the non-hold side like this, and a 12-knot tailwind like this. Everything I'm about to say is equally applicable for headwinds or crosswinds from the other side. Let me emphasize that you should deal with each component individually. You can deal with them in either order. I will deal with the crosswind first, so I'm going to say the crosswind requires 0.2 adjustment to the crosstrack. In this case, we will need to reduce the crosstrack 0.2, so that will be 1.2 miles. I also know that I have to reduce the diagonal distance 0.1. So much for the crosswind. Now, dealing with the tailwind, I will need to increase the inbound leg 0.2, so that will make it 2.4 miles. I also will need to increase the diagonal 0.4. So much for the tailwind. So to come up with the final diagonal distance, I apply both my corrections. In other words, I'm going to add 0.4 for the tailwind. That will make it 3.0. But I'm also going to reduce it 0.1 for the crosstrack change. So my final answer is 2.9 miles. Okay, that's all there is to it. So now we have all the dimensions we need. Let's give it a try. We are inbound to the Vancouver VOR on the 270 degree radial, cleared to hold west on the 270 degree radial. The wind is from 315 degrees at 20 knots, which is a crosswind of 14 knots and a tailwind of 14 knots. These numbers are close enough to what I just briefed that we can use those numbers. Let's get a ground speed check to confirm. 143, that looks like a 12-knot tailwind to me. I'll start the timer at 2.4 miles so we can confirm the inbound leg is 1 minute. Before I get to the VOR, I need to think about what heading I will fly on the outbound leg. I'm using about 6 degrees of correction on the inbound leg. Do you remember the rule of thumb for estimating outbound drift? First, estimate the total time to fly the holding pattern. In this case, the two turns take 1 minute each, and the inbound leg takes 1 minute. But the outbound leg will be more than 1 minute. Let's just take a guess and call it 1.5 minutes. So the total time for the hold will be 4.5 minutes. And deducting 1 minute inbound time, I get 3.5 minutes. Divide that number by the 1.5 for the outbound leg and we get about 2.3. So the outbound drift will be 2.3 times the inbound. that will be about 13 or 14 degrees. So I will try flying a heading of 284 degrees. Just waiting for the flag to flip now. There it goes. Time. Turn right to 284 degrees. Track. The HSI and OBS are already set to 09 or 0. Throttle. Fine-tune for 120 knots. And talk. Report entering the hold. As we roll out on heading 284, I expect the cross-track to be 0.2 more than normal, and it is. I hold my heading and expect the cross-track to decrease to 1.2 as the diagonal distance increases to 2.9. As we near 2.9 miles, my cross-track is going to be a smidge less than 1.2. So I'm thinking that next time around the hold I will adjust my heading a bit. Maybe 282 or so would work better. I rolled into the turn at 2.9 and the cross-track was 1.14 or so. As I roll out, I start the stopwatch and the distance is 2.4, so this will work out perfectly. So all I am considering doing is adjusting my outbound heading a couple of degrees, otherwise we have this hold nailed down. That brings us to the end of episode 3. In episode 4 I'm going to repeat the same hold entries I flew in episode 2, but this time with a stiff wind. I'll see you next time.